All right. Hello, everyone. Welcome. Welcome to Knowit. And welcome to the Databricks Oslo User Group. We're very fortunate and excited to be hosting this event today. My name is Robin Enge. I lead partnerships and sales in Knowit. And together with Pål, or supporting Pål, I would say mostly. We're responsible for building the Databricks community internally in Knowit, which is really fun. If you want to hear more about Knowit and what we do, tap Pål or myself on the shoulder. But you're not here to listen to me, so that's good. We have two great sessions, 3 great speakers. Yeah, first off is Julia and Pål, who's going to talk about news from the global Data+AI Summit that was in San Francisco in June. I was there, Pål was there, Julia was there, and some of the people in the crowd were there, but you know, there were fantastic announcements from the seminar, and yeah, I think it's a testament to what Databricks is doing in terms of research and development, acquisition strategies, etc. So it's really cool. But you guys are the ones who know this, so I'm going to leave it to Julia and Pål. All right.
So, you're spending your precious spare time on us. Big mistake, big mistake. Welcome to this presentation. We're both Databricks nerds. So Databricks MVP we're talking about is like an unpaid Databricks nerd, kind of. That's the content of it, right? You've been for 1.5 years now, MVP, right? And I mean, it's fun. And I mean, what's really nice is that we get a lot of contact with the Databricks product teams and Databricks organization, and they really care about the community, and they appreciate the feedback that we're giving them. I mean, we're in Norway, it's not a huge country, but they appreciate the feedback coming back. So please reach out to us if you have, you know, questions, doubts, suggestions, whatever. Yeah. Yes. And right now, Databricks has huge momentum, $100 billion momentum. So you were schooling me today, Julia. It was $40 billion in December 23. Yeah. 63 billion in December 24, and 100 billion this year, August this year.
So that's a lot of growth.
A lot of growth, definitely. So I mean, it's a big number, but the point is, it's a platform we see growing here. In Norway, in many organizations, big and small, but also globally, we see a lot of growth. And I mean, there's a lot of AI platforms, but proper AI becomes a data questions really, really fast, and then you need a data platform, basically. Yeah.
Okay. My turn? Okay, let's go. So every time I go to a big conference, there is huge amount of news, and they're very technical, and it's like feature by feature. And it's kind of hard to kind of get a summary of it all. So usually when I go to these big conferences, I like to step a bit back. I go away from all the feature by feature things, and I think, what are my key takeaways? And they aren't necessarily specific technology or features, but like, what is my impression of what Databricks is doing? Where is Databricks heading as a vision with their products? And I usually have a couple of key takeaways. So one of my key takeaways with Databricks is the stability of the product. The product is a mature product, meaning when they release new features, it's of quite high quality to compare to other platforms that I worked with before. You can trust that when something is going GA, it's a pretty good product. It's less buggy than a lot of other stuff I worked with in the past. Databricks is a technology platform that is a bit different than a lot of the other platforms because they have more focus on open sourcing stuff that they do. So they have a tendency to, when they develop something really cool inside Databricks, they tend to open source that code to any developer, nerd, and also their competition. So they usually give away their code base and they're like, we're going ahead, you can have our code, you can try to implement it, you can try to take it, but we will just give you the option and then you can decide what to do with it yourself. I will say that Databricks has a key superpower when it comes to the company, and that is that they are extremely good at buying the right type of companies. So what they are very good at is that they're taking like smaller companies that are really good on something AI specific or something data engineering specific. And then they take that company, and then usually within a year, you can see something dropping in Databricks that if you read about the company they acquired 1 year ago, it's almost a one-to-one with the new product they have released integrated into the platform and the company they bought. And that is also, they've spent a lot of time on integrations, not necessarily that all the product ideas come from them themselves. And then we also have this year's summit. There is no denying that a lot of the stuff we're going to talk about today is a direct competition with what is happening in Fabric and Power BI. They're taking a lot of the stuff which we have said before that was a Fabric capability, this was a Power BI capability. And you will see this when I go through the announcement, that a lot of it is like very directly stab on what that platform is doing. So that's an interesting thing. Until now, they have focused very much on being a platform which is very technically mature, and it's not necessarily for everyone. It's been a platform where you have to be a very hardcore developer to use. But after this year, they have been very much focused more towards the business user, your end users, your analysts. So it's becoming more and more a place where they also can feel at home. So we're going to talk a little bit more about that. And I also think that Databricks is very good at having a vision. They have ideas. They have new ways of implementing data platforms. They have a vision of how to bring AI and data engineering together. They have the concept of the lakehouse. They were the one that created the Delta format. They also are the ones behind MLflow as a concept. They're behind Spark as a concept, and the lakehouse on top. And this means that they have they know what they're doing 5 years before they do it. So it's nothing comes as an afterthought, and nothing comes like a direct, oh, our competition did this, so let's implement that into our platform. So I'm gonna focus mostly on the data engineering stuff, and then Pål does usually the AI stuff, and that's usually how we divide the work amongst two fellow nerds. So I'm gonna start a bit with the data engineering stuff. And when it comes to Databricks, they have had some common criticisms from their user and their customers. One of them is that they have had no semantic layer, so there's no way to do measures or something that kind of resembles the whole modeling aspect in Power BI. They have, up until now, not have any low-code options. It's only been notebooks and code, so you have to have had very seasoned data engineers. They have had insufficient reporting. The reporting layer hasn't been something I could say to an enterprise that this is good enough for doing your reports in. They have had no way of having a database option. And they have gotten critics for not being a place for the everyday end users. It's not a place where an end user, which is usually a data platform's consumer, is not made for them. And the SQL hasn't been good enough compared to, for example, Microsoft. So as they have addressed every point of these criticism, they have addressed this year. So one of them is that they have introduced their version of something that is the start of a semantic layer. I don't think it's finished, but at least we have started to see the kind of the vision they have for metrics and semantics. They have launched something called the Lakeflow Designer. They have had a very high focus the last year on dashboards and the Genie. We're going to talk a bit more about that. They have announced that you now have a database inside Databricks. It's an online Postgres database. And they have launched that they're dropping a new user portal, which is basically a portal where your everyday end user or business user can log in the same way as you do in Power BI and just consume dashboards and talk to the Genie, which is your data assistant. It answers you questions about your data. And I would say that they have almost bridged the back on the SQL side. They have dropped everything that has to do with SQL scripting, CTEs, also recursive store procedures. All those enhancements in the SQL experience have been dropped in less than a year. So I'm going to start a little bit with the database. Obviously they called it lake-based because everything Databricks does has the word bricks or lake in it, because they're very proud of their Delta Lake concept. This is actually also an acquisition. This acquisition happened in I don't remember if it was March or April or May, but it's only a couple of months ago that they bought this company. This company is a Finnish company that basically what they did was that they had an online Postgres database. And of course, when Databricks went into databases, they took the only open source database there is, which is Postgres. So it had to be a Postgres database. And it kind of introduces the whole lack that Databricks have had, that they haven't been able to cover what you call this online transactional processing. They haven't been able to cover the fact when you don't necessarily want to take large amounts of data in many rows and process them fast. That is solved by OLAP, and that has been something the Lakehouse is very good at. But what the Lakehouse is not that good at, and Spark isn't that good at, is when you want to find a specific row, alter it, and insert it. So when it's more on the transactional level, OLAP isn't good enough. And that is kind of what the Postgres database brings to the table. Being able to do change rows and then insert them into tables really fast. That's kind of where the magic of the database comes in. And then a lot of people, this created mayhem in San Francisco and created mayhem afterwards, because everyone was like, either they loved it, this is a genius move, finally, and then the rest was like, what the hell are they doing? Why do they try to introduce databases? That's not the point of Databricks. They're just trying to do something that doesn't fit with the rest of their stack. So there was a lot of divided opinions of this. And one of the things it does, it is about this separation of storage on compute. Lakebase is not only a database, it's also where they completely decouple the storage aspect of the database with the compute aspect of the database. Plus, of course, it's open source. And it's also built for AI. It is built for the fact that a Lakebase can spin up a database in less than 1 second. In a couple of milliseconds, you have a total replica of your other database, and then you can just take it down when the AI is done with it. It's kind of a very fast way of spinning up a version of your data and then get rid of it really fast. That is where it really shines. And when AI comes in, that's going to be something they need to solve. So that's kind of one of the main reasons why they did the Lakebase. You have also the concept of branching. So you can look at this as CI/CD just for databases and data. So you can branch out a database. It spins up a copy of that database with all the data in less than 1 second. And then it contains the exact same data as you had in your main database. But if you change something and they kind of branched out new database, you only pay for the data that is different. So you pay for the main one. Then the only thing you pay for the second replica is the data that is different when what's in the main. So where they share data, is the same place. You only store that main data once, which is from a technical point of view, that's quite cool. I have to go a bit fast through this, but so it's more like give you an overview of what the newest stuff is, what does it solve, and then if it's interesting for you, come out and geek with me after on all the different DI things. And then this was something Databricks launched last year, which was the concept of Lakeflow. And I'm not going to go very much detailed into it, but the whole thing is that what Lakeflow is as a concept is basically an umbrella for doing all your ETL stuff and not necessarily writing notebooks and in more pure code, but more towards the low code boxed in version. And it consists mainly of Lakeflow Connect, which is basically your connectors to ingest data from different sources. And then you have this Lakeflow declarative pipelines. Anyone that's worked with Delta Live Tables, it's kind of Delta Live Tables 2.0. So it is Delta Live Tables, and then they added some stuff that they needed because people weren't not everyone was super happy with that product. So it's kind of the new and improved version of Delta Live Tables. So if you tested Delta Live Tables, you didn't like it, you might like this better. And then you have the Lakeflow Designer, which is a no-code solution for ETL. I'm going to look at a quick sneak peek after. And then you have Lakeflow Jobs, which is basically where you orchestrate all these things. And as I said, Lakeflow Connect, that is actually something that's built on, this is actually wrong, it's not the acquisition of Neon, it's the acquisition of something called Arken, which was a company that did a lot of connectors into any legacy data warehouse or database or something. So it's basically a suite of connectors, and you can it supports incremental syncs, it handles schema changes, and you have basically click, I want to connect to this type of database or this source system, and then it ingests that data for you when you choose the table, and then you can also track historic records, and it only reads the incremental changes. So it's kind of handles the whole thing that Databricks wasn't really good at ingestion. So they're that's a suite that is kind of evolving a lot. And per today you have Workday and Salesforce, which is like GA connectors. And then you have Google Analytics and SQL Server. Both of them are public preview, which means you can use them in production. So all of these 4, production ready. And then you have a SharePoint that is coming soon. And they also have had a roadmap of a lot of other stuff, which is, for example, Dynamics 365. So they're going to get a direct connector to Dynamics 365, which is very interesting for the Norwegians because Microsoft is everywhere in Norway. And then they have also Oracle. So if you Google it, you will get a bunch of roadmap on different connectors that's coming. So this is kind of just the start of that. And of course, it requires serverless, like most of the new stuff does. So we just hope that comes to Norway soon. I just want to take one quick look at this Lakeflow Designer. This is what they have published out. And what it is a no-code solution to do your ETL. And I'm a data engineer by heart, an architect, so for me this is really scary. And I don't know what I think about it yet, because I haven't tested it. Or I've tested the beta version, but yeah. The whole concept is that you can talk to the tool with natural language, and you can say, I want to join these tables together, and it will give you a task. Translates that, it pops up and gives you a lot of boxes. Every box is SQL in the back. That means that you can always check that box, check the SQL, see if you agree, and change that SQL, and then the box will kind of do that instead. Or you can do the other way around. You can go in, write your SQL, and then it gives you a box. And the concept of this is really cool if they can make it work, because you will still have the ability to kind of steer it in the right direction, and you will always know what's happening in the box. You can always get the kind of technical implementation in the back. So that's interesting. And then we have my favorite product in the whole world, which is Unity Catalog. I usually say that Databricks' greatest strength is acquisitions and Unity Catalog. I think everything in Databricks is synced in this catalog. And as long as Databricks continue to have a tight integration from Unity Catalog to every new product, they will be, in my opinion, my favorite tool. The moment they slip up and start launching things that doesn't have a clear connection to Unity Catalog, I think they will lose their biggest advantage. And as always, there have been a lot of there's been a lot of announcements on the Unity Catalog part. So I'm gonna talk about my favorite ones. One of them is Unity Catalog metric views. So until now, this has been really the most normal setup there is for Azure Databricks, which is what I focus most on. You have your medallion architecture with your notebooks, your SQL editor, your Unity Catalog, your dashboards, and your Genie. And you do the medallion in any way or shape or form that you like. And then you push out this data into Power BI and you create reports on top. That has, up until now, been the most normal pattern. And what happens? Today's your measures, your business rules, your calculations are created here. It's created in Power BI, and it's created usually by the analyst. So, and then you have your analyst, he lives here in this layer. And then you have your data engineer, he lives here. And then this guy, my data is wrong. Okay, your data is wrong. Why is it wrong? And then these two have a really hard time trying to take the measures here and kind of replicate them all the way back here to try to figure out where the data is wrong, for example. That's a common pattern. And these two don't talk the same language when it comes to calculations and KPIs and numbers, because they don't see the same thing. The whole point of Unity Catalog metrics is the concept that you take your measures from the end of the solution and you put them in the heart of the Databricks platform, which is the Unity Catalog. That means that anything in your in Databricks can consume the same metrics, the same calculations, and you will be able to access your measures from notebooks, from the SQL editor, from your dashboard, from your Genie. And other third-party tools are also welcome to consume these metrics. So that's kind of the whole idea. And this is probably one of the things that I was most excited about in the summit, because it's a really cool concept to take this challenge of your measures, because they are kind of the end product and they are something that is really important. So why do we have to put them in then? If we can make, I'm not saying that it's going to be easy, but if you can take it and put it in the heart of the platform, that would be solve a lot of problems and spare a lot of people a lot of time. So how does it works? Basically now they are a form of view, which are defined in a YAML file with like SQL underneath. And it can, I think that's gonna change. Right now it's just supported to do YAML file with kind of SQL inside. Quite easy to get started. I've tested it myself, but I don't think that's gonna be the only option for very long. They're probably gonna start to do a bit more that you don't have to do the whole YAML things, because YAML is a word that scares a lot of people. So I think they're gonna make it, or they have already said that that's not going to be the end results, but that's kind of the first iteration, because this is just the first iteration of the idea. And right now, this was also a discussion under the summit. Right now, these are the other third-party tools that are metrics partners, which means that they read Unity Catalog metrics. And if there's one thing anyone in Norway sees here is that where is the 3 yellow things and where is the big green F? And it's not there. And we don't know if it's gonna come. We don't know if it's on the roadmap. No, Databricks haven't said anything. Microsoft haven't said anything. I would guess it's not in Power BI's the greatest interest to move one of their hard stuff into Unity Catalog. So they're probably resisting, and Databricks is probably pushing to make it happen. But we don't know anything. So right now, if you have Power BI, you need to, if you want to use both, you have to do both metric views, and then you have to rewrite and do measurements in Power BI. So the roadmap for that, we don't know. This is a really nice one. We heard about it last year. I waited for a year and I didn't hear anything, and then they launched it now in preview. Attribute-based access control. It makes GDPR simpler. You probably don't have to use all that time on doing GDPR. The whole concept is, I'll just take one quick example, and that is, let's say you have a lot of emails and you need to mask all your emails. And these emails, they are around in different tables, in different catalogs, in different schemas. So what you can do is say, I have this function. This is the way I want to mask emails. You give it the function. This is how I want to mask emails. Then you go in Unity Catalog, and you can help Unity Catalog by saying, tag it with email, 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 email. And then you can say, using this product, you can say, okay, now I want you to apply this function on any column that is tagged with email. And then you can choose, should it apply on this table? Should it imply on the whole schema? Or should it work on a whole catalog? And then you just choose the level you want to mask it. And then if you choose a catalog, it will just find every column that's tagged with the email, and it will mask it for you in one go. And it kind of works that way also. So if I later create the email, it will automatically mask it because it has a rule on that catalog. And that is a pretty cool use case. And I think it can save people a lot of time. Me as a data engineer, not especially interested in masking emails manually. So this means that I have more time to do other stuff, basically. And it has a lot of nuances to it. It now also has a data scanner function, which means you don't have to tell it it is emails. It just scans the data and finds the emails itself. And then you have some other stuff. You have a discover page, which is like a place where you can easily go around in different notebooks, dashboards, Genie spaces. So it's kind of a cataloging classification place. The place you go to try to find what you're searching for, basically, in one place. That's cool. That is coming. It's not come yet. Then you have the whole concept of certification of things and deprecation. The same thing you do in Power BI with, you can certify a data set, you can deprecate a data set to tell the users is this active or not. Then you have a cool button that is request access. So you go in, you see a dashboard. I want this dashboard. You click request access, and the people that own that resource can approve you. You don't have to go through a million different people or some IT system on the side. And then you have the domain, which is basically, here's your market data, here's your sales data, here's your whatever data. And then they're also launching a data quality monitor soon. That's going to be things like data in this table is that and that fresh, or yeah. I'm not going to talk a lot about it. It's not any like major announcements on this part, but I will say that if you haven't tried dashboards or Genie the last 6 months, you should give it a go, because the momentum and the improvement of the dashboard experience now compared to when I used it 1 year ago, where I gave it a score of maybe 2 out of 10, is quite another score than I would give it today. It is not as good as Power BI, but it is coming so close to good enough that it's not necessarily worth paying for a F64 capacity anymore. So it's more of a, is the difference between them big enough to invest in Power BI Premium? For some, yes. For some, no. And then this is basically the last one, which is the Databricks one. It's the user portal. They're launching this probably in preview sometime before Christmas. It's basically a user logging for all your end users so they can see Databricks dashboards and or Genie spaces. So yeah, then we can skip that one because you will cover.
Thanks a lot, Julia. With the Power BI, possibly being not needed, is also the architecture simplification that signifies for other organizations. So you don't have two platforms anymore; you have one platform, right? So that's a huge thing, and I think it's also pretty huge because Microsoft is attacking Databricks with Fabric, right? So it kind of the attack goes both ways, and they say you don't need Databricks, we have Fabric, and then Databricks says you don't need Power BI, we have dashboards, right?
They're coming closer.
Yeah.
Yeah.
So I mean, it was kind of bound to happen. So I'm going to talk a lot about different AI launches. They're coming fast, so I'm not going to cover all of them. The first one is Agent Bricks. Anyone here heard about it already? Either you're very shy or there's only one person that heard about it. I see one person at least. So Agent Bricks is a no-code platform for AI agent refinement. You get agents that can auto-optimize on your data. You get automated benchmarking and deployment. You can curate apps with human instructions. So basically, it's like, you have your agent. It's kind of cool, but it misbehaves. How do you then deal with it? And I mean, we had the hangout in the European Databricks Slack community yesterday where we talked about, what's this thing? How can you use it? Can you use it? And I think it's a tool that, it serves a few purposes. It serves the purpose of getting somewhere along the way to prove the validity or usefulness of an agent. It probably does not give you a full risk management in a risky AI agent context, like should I or should I not cut off this arm because of this diagnosis? Maybe it's not going to give you a good enough answer to ask the agent that if it was a health care service. But it does point to that the human coding agent interaction is complex and is moving somewhere, and Databricks is trying out a lot of different stuff there. So they have like the TAO, which is a model pre-trained on a bunch of enterprise questions. So if you want to build like a golden data set, basically a validation data set for your agent, then you don't need the answers because it kind of deduces the answer from similar enterprise questions. So there's a lot of innovation there, and Databricks is moving fast and they're moving open. And I think that gives them a huge advantage compared to a lot of the other players. So Arnie, another MVP, said yesterday, if you want to try it in the US region, because then you get more functionality. I'm not sure if you even get it in Europe, but you can get it in the US regions, both on Amazon and Azure. So Databricks Apps is a fully managed serverless runtime for apps with access management from Databricks and user management. So it means I can let your users into this app and know what data they should see and get visualized in the Streamlit app or dashboard or API or whatever. So it's very powerful because it's inside the Unity catalog access management. And I think it's going to be something that's going to solve a ton of problems. For example, API for front ends, deploying complex multi-tool agents, all kinds of like things between a full app and a data platform tool. And you can basically leapfrog a lot of the hardcore cloud engineering you would need to do to deploy these things. So that's super recommended. to try out and to consider. I mean, do reach out if you have like questions on, what's the purpose of it. And there's a lot of open questions even, within Databricks about where this is going. Databricks Free Edition, very cool launch. So I heard it being said, the YouTube of data, right?
It's good. It's good.
Yeah?
I used it a lot. I'm gonna do my full day workshops using only the free edition from now on. And it's you can say the rest.
Yeah.
I just wanted to say that it was cool.
This might work actually also. So if you want to interrupt me, you're welcome. So the thing is that you get a Databricks platform, you get it for free, and I mean there's a number of things here, right? For learning, for getting to know the platform, for students, for universities, but it's also for open data. So I think that the vision is broad. We don't know where it's going to end up, and that makes it very exciting. Lakeflow declarative pipelines, you mentioned it already. What's very interesting is that they open source it, so you can do a lot of like CI/CD locally, or in a GitHub Actions or whatever. So if you want to test your pipelines fully offline, you can do that, and that's super powerful. And I think it's also an act of good faith that they open source a core functionality like that, right? I mean, my impression from my totally scientific gut feeling at the conference was that, the people running Databricks are nerds, and they like nerdy stuff, they like code, they like open source, and they release a lot of this stuff because they like it. And, I mean, Apache Spark itself is open source, right? Obviously, there's a business model, $100 billion business model. What's very cool, though, is that you get the UX interface is improving a lot. We've had a few meetings with the team, and they're really keen on feedback. They're doing some really cool stuff and really try to make the experience of building Delta live tables much better, or LDP much better, because it used to be a bit confusing. It was a notebook, but then it wasn't a notebook, etc. MLflow 3.0 redesigned for generative AI workflows. It's a huge slide. The time is kind of running, so I'm not going to go through all of it, but there's a lot of focus on generative AI. MLflow is the industry standard. It's probably becoming an industry standard for generative AI apps also. It's supported in Snowflake, AWS SageMaker supporting it. For example, they have developments like making prompts a first-class citizen in the MLflow entity hierarchy, or not hierarchy, but a system. So you can actually say, this is my prompt version 1, version 2. It ran together with this version of the model. And then you actually can systemize that also. And it takes into account the human-in-the-loop feedback, which is crucial for building the agents, to get that feedback from the clients. And then there's stuff coming like, prompt optimization, automatic prompt optimization, etc. When you want to do anything beyond the sort of hello world, cool, look at my RAG agent, then you need to be systematic, and then you need a system for it. It can sometimes be a little bit expensive if you just go straight for the tutorial notebook and run that in your environment. So do watch out for the MLflow costs and the tracing jobs, and you can turn those off or turn those down. Or you can even do stuff like running MLflow against a local database while you're doing development. Serverless GPU compute. Basically, you can do GPU stuff, which you want to do as a data scientist, without having a GPU cluster. Super powerful for a lot of use cases. Let's say you want to run a custom, small, like Gwen model for using as a tool selector, a small model. You need a GPU for it, but you can't pay for that GPU 24 hours a day. Those use cases in Norway are, hard to pay for, at least in the early phases, and at least if you want to do the dev environment and the staging and the product environment. And then the cost management, obviously. Databricks asset bundles, I've kind of been like, you know, a little bit nasty to Databricks asset bundles before. Geir likes them, and you know, maybe it's just a petty, you know, perspective from me, but I do think they're becoming very good. It's not just YAML anymore. It's becoming super powerful. You can do Python with it, and it's now visible in the UX also. So actually, if you have a bundle inside your domain folder somewhere, it's gonna change the UI slightly, so you actually see that you're inside a bundle, and you can very soon do custom templates. So that's super interesting. Let's say in your organization you have some default data job, default AI job. You can have a template for that, and you know, have a script or some meta notebook or some way of instantiating that. Or people could say create new bundle, then select it from a bundle template, and you would basically have an out-of-the-box data context or AI context. So that's becoming very, very powerful. And also note that the Git functionality is now full in Databricks. So you can go inside a web terminal or in the notebook and do like Git merge, Git rebase, all of those advanced operations. Yeah. So I do wanted to mention also that Lakebase is super interesting for AI use cases. A lot of the agents, they need to spin up really fast a database. Databricks themselves said that I think 60 to 80% of the Neon databases online are spun up by agents, not by humans. So to be able to do that fast is very interesting. And I think it's going to be, I suspect there will be a vector search based on Neon that's going to be serverless. So you would have a serverless vector search. Again, that's super useful because vector search can be expensive. How many here have tried vector search and had to turn it off because of cost? Mattis, you're on my team, so I counted on your vote for that one. Very good. So, conclusions. What actually happened at the summit? So, Bruce Lee, born in San Francisco. Maybe some of you didn't know that. But he was a very, very innovative person. Like, he did a lot of innovation in his domain, and he said a lot of really wise things about, you know, knowledge in general and human practice in general. And I mean, what is actually happening at the summit? I think one very interesting thing is that the carpeting of systems is kind of almost going away. Like all the cloud engineering, you know, spinning up this custom Postgres database and scaling it, or, you know, building your ML ops, Kubernetes clusters, etc. Those things are kind of being taken care of. And how do we adapt to that? What does that mean for us? How does that change how we work? And I mean, another aspect you see is that the approaches of like agent human coding interaction is sort of a very early iteration of this kind of jazz where you're trying to figure out how you do things, building some kind of interaction there, multi-agent, crew AI. I mean, there's so many approaches, but it's very early. And I mean, what we've experienced when we built agents here or for clients is that you really need to think about where do you give freedom to the agents and where do you actually enforce them to do this or that. And again, data governance is hugely simplified. So it becomes much easier, even with AI-assisted data governance, to actually do proper AI governance. And I was like, yeah, cool, very cool. And then I think it was you that told me, like, okay, but what if, I mean, will we have a data democracy, or will we have a, in Norwegian we call it pøbelvelde, or anarchy, right? So it's like, if all of these people can suddenly make a bunch of AI and data assets, what's the consequence of that, right? And to to end with a quote, I think that Bruce Lee said that it's not a daily increase, but a daily decrease. Hack away at the unessential. And I mean, Databricks has, for us, they're hacking away at all the unessential work. We're ending up with a pure data work, kind of. And then he said, all types of knowledge ultimately means self-knowledge. And I think that what you cannot escape from is understanding the business, understanding the problem, understanding what you need to do and want to do. And especially with agents, it becomes super obvious that when you want it to reply on your behalf, you need to know what are your actual principles or opinions on what you want it to reply. Finally, this slide, it has this technology, QR code on it. It's the Euro Databricks Slack community, which you can join. It's a Slack community for your Europe-based practitioners. So like if you have some connection to Europe, you want to join. We do hangouts once or twice each month. Geir was there last night, shared his knowledge. That was super interesting. So do become part of that. Next session will be Tuesday 23rd, and then we'll have Databricks MVP Dan Williams demoing a data ingestion engine that's integrated into Lakeflow. It's a little bit... Yeah, the connect part. Lakeflow connect, right? I mean, he didn't allow me to say a lot about it. So it's a little bit mysterious. But he's a great professional, so I invite you all to join that on the 23rd. And finally, if you can still take coffee, there's coffee there. And there's more food, so please serve yourself again if you want to. Thanks a lot. Yes. So we're about to start again. And I'm very excited to have Geir here, because Geir his team has done a lot of extremely interesting stuff at Gabler, pension fund manager, sort of. Yeah. A lot of very interesting stuff, a lot of very interesting integrations between Excel and Databricks, how to onboard teams working with Git and DLT. So there's so much real-world experience here, and Geir is always very contributive in community issues in general, doing talks or answering questions. So I'm looking forward to this, and the topic today is SQL nerdy, but in a very good way, I think. So let's give him a hand of applause.
All right, do you guys hear? Yeah, you hear me. I can. You go for sure. You hear me. All right. Okay. Yeah. So I'm going to be talking today about how to replicate a SQL Server schema in Databricks Lakehouse. Now, I started tinkering with this quite a while ago, and then Databricks came along and they came with the announcements that they have Lakebridge and Lakebase, and I was wondering, well, is there room for my solution? I will say yes, but we'll get to that. And yeah, so the idea then of this talk is to use system tables from SQL Server and replicate the tables, the primary keys, the foreign keys into Databricks. I will show how I do this, and then we can discuss. And I will also talk about the architecture, general architecture. There's an architecture pattern that I'm trying to promote within Gabler, based on the medallion architecture. And yeah, we'll also talk a little bit about data ops and that kind of thing. There are a couple of faces that saw me on Saturday, so there will be sections of this that are familiar, but you'll just have to bear with me. For all the new ones, hopefully this will be interesting. All right, okay, so enough preamble. About me, who am I? My name is Geir, I'm 45 years old. I do 3D ops, I do data ops, I do diving ops, and I do data ops. Not necessarily in that order, but that's who I am. I'm originally an economist. I used to work in the Norwegian Central Bank. I then transitioned over into data scientists, mainly scientists, I suppose, at Kantar. And then I worked as a data engineer at the Lillevold and Partners. And I made this transition, by the way, because I discovered I was a horrible economist. So, you know, I was much better with data. So anyway. And then I'm in my current role now, Chief Data Architect at Gabber. And yeah, so and you can reach me in those places. And this is a picture of me in my favorite suit, I suppose. All right, okay, so data engineering in Azure Databricks. I always like to start off with the reference architecture. This is the reference architecture in this is official Azure Databricks reference architecture. And today we are going to it's going to be sort of broadly divided into three main parts. I try to allude to that. We're going to be talking about the data pipelines or the bloodlines, as it were. And in this case, we're going to go from SQL Server. We're going to use a Lakehouse Federation, and then we're going to use Spark and regular old Python and PySpark or SQL to do some transformations. And we're going to get that into our medallion architecture, standard way of doing things. And then we get to the data engineering circle of life, which essentially are Lakeflow declarative pipelines into the medallion architecture, and then, I guess, federation lineage. So it didn't entirely line up, but that was the idea. So it's the data engineering circle of life. Okay, so there you go. Anyway, and then it's the data engineering process management, which then, so data Lakeflow jobs governs the pipelines, okay? And then data ops CI/CD tools governs both the jobs and the pipelines. And this then, in totality, is the life of a data engineer in Databricks, all right? So we're going to be mainly focusing today on federation, SQL Server, and getting stuff in. I just wanted to give you this kind of general idea, because one of the reasons why we're doing all this is, for me as a data engineer, I want to use Lakeflow declarative pipelines in order to incrementally ingest my data. But we are not going to be talking about today. That we can talk about that at a later stage. All right, okay, so the problem then. Yeah, so it was the pattern I'm going to present was born out of a need that I had to navigate the schema. And I'm very happy that Lakebase is a thing now, because then, you know, I'm an OLTP guy at heart, and now I can get back to OLTP stuff, and that's great. I love it. And since we heard a lot about AI, we always hear a lot about the AI. I'm marginally interested in that. I'm much more interested in database stuff. So we're going to start at the beginning, where everything starts with the normal forms. Now, who amongst you know what a normal form is? Some people know what a normal form is. Great. All right. There are multiple normal forms. We're going to do this super quickly, and then we're going to focus in on the ones that are important. There is the first normal form. There is, you guessed it, the second, the third, the boys' cod for some reason. There's the fourth, the fifth, and the sixth. These guys are the most important ones. And for our purposes as data engineers, we only really care about this one, okay? Because if you got third normal form, this is the standard way of normalizing any database. Once you achieve this, you're pretty much golden, and you're in a good state. If you are like me, and you've ever read world's most important book, which I highly recommend, you know that the third normal form crops up 9 times out of 10. All right, okay, so third normal form. What is a third normal form? Essentially, you just need to have a key, right? You need to have a primary key that is unique, and it's the minimal key that defines a table, okay? This is the main concept, and it's super important. And this gives rise then to the saying, I need the key, the whole key, and nothing but the key, so help me COD. Because COD is, anyway, yeah. Sorry, explaining jokes doesn't really work. All right, and then we move on to database keys. So a key in a database term or in a table has multiple sort of properties, okay? So we got the super key, which is a set of one or more attributes that uniquely defines a row. That's a key or a super key. A subset of the super keys are the candidate keys, which is a minimal set of attributes that defines a row. And then you go to primary key. Now, what is a primary key relative to a candidate key? A primary key is the absolute minimum that you can get, or the absolute minimum number of attributes that defines a single row. It's one of the most important basic concepts in databases, and you need to have, essentially, you need to have a primary key, or else you haven't got even the first normal form, okay? And then finally, you have other relationships, because a traditional database is called a relational database model. And why is it called relational? Because there you have table 1 and you have table 2, and there's a relationship between them. That relationship is defined by the foreign key. So these are the key concepts. And I mention this because what I want to do then is I want to transpile the schemas into Databricks. Okay? So, and I said I was going to use system tables. The system tables that we're going to be talking about are a specific set of system tables. There are multiple. But these are the ones that are important. Schemas, tables, partitions, allocation units, indices, columns, types, foreign key columns, and index columns. You don't really need to remember all that. I just wanted to sort of give you the outline. And on the Databricks side, you have catalogs, schemas, tables, columns, table constraints, key column usage, referential constraints. These are our protagonists. Okay. And now we get to, I wanted then to show you how I build these queries. And I'm going to start with the SQL Server side, and then we're going to get to the Databricks side. All right? I'm not entirely sure how this is going to work, but we'll try. All right, so. No, sorry. Yes, sorry. Before that, I need to talk about how we get our data, because that's important. So we use Lakehouse Federation, as I said. Lakehouse Federation comes in two flavors. It's the query federation use case, and it's the catalog federation use case. Now, we will be talking about everything I'm going to be discussing today, essentially is in this bucket. This is not really relevant, to be honest. It's only Hive, so I don't really even understand why. I mean, but whatever. These are kind of the key use cases then. So this is what Databricks says that you should use query federation for. You should use it for ad hoc reporting. If you want to minimize data movement, when your source system supports both Lakehouse Federation and Lakeflow Connect, Databricks recommends to use Lakeflow Connect if performance is higher, or if you have higher data volumes. This one is what I'm hoping to get to. But for the moment, I am constrained to suboptimal query federation. Because Databricks has mentioned that part of the news that was released was that they will start, because currently the Lakehouse Connect supports CDC from SQL Server. Anyone knows what CDC stands for? Fantastic. 10 out of 10. I love it. All right. So it does support CDC, but in order to implement CDC on SQL Server, you need to start off, or you need to start change tracking at the very least. And in our case, we can do that, but I am hesitant because, you know, it's a source system. I don't want to mess with it too much. So I'm happy that Databricks will come out with an enhanced version of this, where you can do that by query, which is going to be, for my use case, very, very good, and it resembles what I tried to do. He said, only slightly braggishly, but anyway. So that's what I hope will happen, right? That it'll make my life easier, because let's face it, it is not easy. All right, and now then we get to our first SQL query of the day. This, sorry? Okay. You can ask questions, by the way, if you want to. So this table, or this query, goes away to SQL Server, and it asks SQL Server to give it all primary keys. And the objective, right, is I want to get both primary keys and foreign keys in a square or in a table form. So I join all these together. And this also is an example of query pushdown, because this is written in Spark SQL. What happens when you do Lakehouse Federation is that the query is pushed down via JDBC to SQL Server. It's transformed into T-SQL. And then the query runs twice, and the data is moved across. So it's not super efficient, but it kind of works, right? So that's basically what happens, and that is why you can see, if you for the ones that are noticing, this is not Transact SQL standard stuff, but it still works. Okay. Okay. Foreign keys. It's the same, pretty much the same thing, only slightly more advanced. You do need foreign key columns, and you need to sort of have what I wanted to do here, of course, is I want to get both the referencing tables and the columns. All right? Yeah, do ask questions if you're interested in this stuff. But and then we need to do column mapping. Again, this is something that Databricks now has solved for me. So I hope that this will be easier. But my current way of doing this is I have analyzed all the types in our database. And I have said that whatever they are, I will then use Databricks types. These are the Databricks types I use. I use string, I use big int, I use decimal, binary, timestamp, and variant, which is one of my new faves. Variant is fantastic. But I'm not going to be talking about that today, more than just saying that it's fantastic. All right. And then I threw this one in because it also shows other stuff that you can do with system tables in SQL Server. You can figure out what size are all of my tables in SQL Server. And this is super helpful. I use this a lot in order to say, well, I know that some tables are populated, others are not. So I use this to figure out which tables actually are living in SQL Server. All right. And then we get to the Databricks side. And here you see I'm a little bit sort of, I go back and forth. Sometimes I write Python, other times I write SQL. It doesn't matter as long as it gets the job done. This is an example of a Python query that I wrote. This is for information schemas in Databricks. So there's table constraints and there's column usage. And this one then finds primary keys because it says primary key. And then there's foreign key mapper. And this is a very, very long query. This took me a while to figure out. But yeah, it does the same thing as in SQL Server. It gets all of the foreign keys and all of the relationships in a table or in a data frame, I suppose. All right, so having spoken a lot about the sort of the general what I'm trying to achieve, how basically I'm doing it. I'm going to also then try to show stuff that you can do once you have all this information in Databricks. What are some of the interesting things that you can do within Databricks? All right, so because one of the things that happens, and this is the, okay, it didn't switch, crap. All right. Should do it now. Okay, right. I'm gonna have to. We'll see what happens there. Okay, right. So this is a database that this represents all of the tables in an actual database that we have, and I'm going to show what you can do. There's a table that is called legal party in our universe, and you see this little button here, and it shows me the relationship. And of course, this is probably the same underlying technology as in Lakebase, I imagine. Yes? I mean, what it actually says is not important. The important thing is that you can do, because what happens, right, is that you see that it's called foreign key, and then it shows up that, okay, so which table does it go to? In this case, it goes to a table called business transaction. I can click that, and I get into business transaction. Now, business transaction is in our database, the heart of the database, which is why you see no more view relationships. Everything points to that table. So, you know, I'm gonna have to go back then to make it interesting. But if we do this one, for instance, you know, you can hop to that one. And then you can do view relationships again, and you can see that, okay, there's another relationship. I wish that it was a total relationship graphic, but unfortunately it is not. So maybe we can pester the production team or the product team, Pål, to give us this, because that would be super helpful. Okay, so that is that. That is kind of from the. There's other bunch of the interesting things you can do as well, and one of the things is. I hope my cluster is still running.
Question, Geir.
Yes.
So what you're showing now is that you've imported the bronze data, but you also imported the relationships between those tables.
Only the second part of that question is true. I've only imported the schema. I'm not, so doing the actual data import is very similar, but my goal today is to show how I can replicate the schema, okay? And the actual loading is similar. I can do that as well, but that is not the topic today. Not the actual loading, just the replication, showing that way I can use. I've established a connection, and then I can move the data across, and it's one-to-one, exactly the same.
You don't lose that information.
Yeah. I mean, and that's the thing, right? I wanted to achieve multiple things. I wanted to achieve parity in the schema. I wanted to because our database is riddled with Pascal case, and I hate Pascal case with a vengeance. So I wanted it to be snake case because I really like snake case. So I rename every single field is renamed into snake case, and the table is renamed into snake case, and all of the types are being changed so that I reach my end goal of having a Databricks compliant database, but still it matches one-to-one with the underlying SQL. Okay, so what I wanted to show then is I wanted to show that once you have the data in Databricks, we can find things like the shortest path between two tables. All right, and in this case, I'm doing it from any given table to this magical table called business transactions, which is our core. And here you see So this function gets all the foreign keys from Databricks. And then I just basically print it, and you get something like this. And so you see all the paths, right? So sometimes, most of the time, you know, there's only one hop to get to business transaction. But this guy, for instance, from the table cover base, it's 2, 1, 2. And that's the shortest path, right? So that's interesting, because if you're doing modeling, sometimes you want to know. And what I'm trying to say is that with this methodology, you can then stay within Databricks, but you can still figure out, how do I get from A to B? What's the shortest path? That's important for me when I'm doing my data engineering. All right, other things you can do is you can print all of the dependencies, right? That's another function that I've written. And then it just lists out, essentially this is just a graphical view of what I showed you earlier, right? This is all of the dependencies. So all of the tables, and it links to what, and it just gives you that. Just wanted to give some examples of interesting things you can do with Databricks system tables once you have all of the data within Databricks. All right, okay, so demo over, and any questions to this? Clear as mud? Okay, one more question, yes?
Can you explain the use case in data engineering where you have used this kind of mapping, or could have used this kind of mapping?
Yes. So the primary use case is that our database is a very complicated database. It's two-dimensional. So you've got a relational database, and then you've got some documents. And what it does enable us to do is to split those documents from a multiplex universe to a singleplex. Okay? And that was super hard to do, and this is just a way to actually make that transfer possible. And all of it in a metadata way of designing the pipelines. Right? So I wanted it to be as little. Well, there's a lot of code, but I didn't want to be. I wanted it to be as you know, not brittle as possible. All right. Yes, go on.
You just read data in Databricks, I suppose.
I'm sorry, what?
You just read data in Databricks.
I just read data in Databricks.
Yes, I think, for example, you don't want to implement something like cascading delete or stuff like that.
Sure, I can do that. Why would I? I mean, I can do that.
Okay, so you can implement cascading delete to.
Oh yeah. Yeah. I mean, I could have shown that, but let me see if I can switch back. No. God damn it. All right. Okay, so it's this one maybe. Oh, very difficult. All right. Super hard to make it switch. Okay. Yeah. So all the way to the top of my, just to sort of answer that question, yes, you can do cascading deletes. Here. So you can, or where here, see? Cascade. All right, so let's continue. Okay, so I've tried to give you then an understanding of what I'm trying to achieve. I tried to show you how I achieve this, and then we're going to be moving over into sort of the tooling, the supporting tooling within Databricks, and we're going to get to one of my favorite topics. It's called asset bundles. There were some criticisms earlier, but we ignore those. Asset bundles are great. But yeah, I mean, they for sure, they could get better. Essentially, it's a way, for those of you who haven't heard about asset bundles, it's a lightweight Terraform. Essentially, you can think about it like that, and it governs cloud infrastructure and workspace configurations within Databricks. So you push everything from code into Databricks. It's very robust, and it's sort of surprisingly nimble. YAML, different story, but you know, it is what it is. All the business logic is in source files, and the resource definitions are set in YAML, or now, soon to be Python, I suppose. Okay, we govern this using Databricks jobs. In my view, a job should be used to orchestrate the pipeline. So the pipeline is what does the transformation. The job acts on the transformation. All pipelines then should have an accompanying job. And the jobs are general purpose and can orchestrate a variety of tasks, not just pipelines. And pipelines are specialized for data engineers. Okay, so we use a bunch of external tooling. I highly recommend local development. Again, people very often sort of default to the online GUI. I've started using local development. I think that's much better, just to sort of get a sense of what's actually going on. But that's because, you know, yeah. And we do all our dependency management with UV. What these two in conjunction allows us to do is to get an enhanced understanding of what Databricks actually does, or at least that's my view. We develop our pipelines and our jobs locally, and then we try. This is aspirational more than actual fact right now, but we do test-driven development. Okay, so I said that there are some new contenders in town. There is Lakeflow Connect. I mentioned that's what we're looking at to switch out Lakehouse Federation. Lakeflow Connect comes in two flavors. It's the SAS connectors and it's the database connectors. This is going to be a little bit of a rehash, so I'm going to be super quick. Essentially, I don't care about this. I only care about this. SAS is Salesforce and stuff. Not important. Not to me, anyway. This, of course, is very much important. So this is where you got your SQL servers. This is where you got, eventually, I'm hoping, there was on the roadmap, it was DB2, because we are still in the DB2 world. So fingers crossed that DB2 will actually come to be, but who knows. Lakebase, or make OLTP great again. This was fantastic. I love it. I love it so much. OLTP is coming back, baby. So it's open. It's built on Postgres, that was mentioned. It's a decoupling of storage and compute. Serverless architecture, built for AI agents. Lakehouse integration. That's I suppose is coming. And then there's reverse ETL. I don't know if you mentioned that, but that is, to me, one of the most important use cases. Because this allows me, right, to put all of my analytics pipelines and stuff into a database that is easier to query than maybe the Lakehouses. Hopefully. And then there's LakeBridge. So LakeBridge is a tool that was also recently announced, and that does migrations for you. It looks a little bit, I looked at it. I haven't tried it myself. I looked at it. It looks a little bit clunky right now, but it's bound to be get much better. And essentially, this is what does all of the work I showed earlier. More or less, this does most of it. So fingers crossed that will be. So yeah, it comes with the following capabilities: the profiler, the analyzer, the converter, and the reconciler. Okay? Of these, probably the one that you're going to get most bang for the buck is the reconciler, because then you can go and you can show to your business users that you have migrated your database, and it is your database, okay? In terms of it gives you column counts and data quality metrics and all that stuff. So that looks super interesting. And in the Lakebridge ships with 2 transpilers. That is the Blade Bridge, which is that's the one that so Blade Bridge was the original company, I think. Yes, thank you. And another one called Morpheus, which I know nothing about, but that's probably great, even though it sounds sleepy. But you may bring your own, so that's interesting as well. So this for sure I'm going to be looking into once I have a chance. All right, now we get to what I call the architecture. Underpinning all of this is the medallion architecture. Now, the medallion architecture is an obstacle to understanding, in my view. It doesn't say what it is, and it's super hard to explain to anyone what it actually is. So I have come up with a sort of a way to try to explain it. So this is a traditional medallion. The medallion essentially means that you have schemas within a catalog, and you have multiple tables, and they work together to give you a report. Done, pretty much. And then, presumably, you have multiple catalogs, each with their own bronze, silver, gold. Now, if you have 10, 20, 100 catalogs with schemas called bronze, silver, gold, how are you going to find your data? What does this mean? It's super hard, right? At least I think so. So I tried and failed to explain this, and it's just a nightmare. So I came up with what I call the medallion domain architecture. Now it's the same thing. It's not, new, but it's just shifting the aperture slightly. All right. So rather than being schema, it's still granted it's still schema, but it has one super schema that has all your raw imports. Call it the warehouse, right? And then you have sort of conjoining schemas that take only the tables that it needs, and this is then the pipeline. And the pipeline has bronze, silver, gold. And this then is the refinement. And I believe that this is what Databricks actually meant when I said the medallion architecture, or its original name, the delta architecture, right? So that way, you have if you think along these terms, you have a catalog, and then you have schemas that produce, and each schema is a product, and each product can work together to produce a new product, right? So the products build on themselves. And then you get to the medallion spoke architecture, which is my, little. This is mine, as it were. And essentially, what I try then to show here is that these boxes now, the bronze, silver, gold, they are logical constructs. They are not physical constructs within Databricks. And you have all the schemas that are working together. And then, so essentially, then a catalog has domains within it, right? And each domain is represented by a schema. And then you can say meaningful things like, I have this one schema, which is called, I don't know, in my case, business domain 2. But that's different from business domain 3, right? And it makes sense because, and this is where you sort of get to the end of it, the medallion spoke architecture, I've tried then to map the Databricks concept to a semantic name. All right, so you have the meta store that maps to company. You have the workspace that maps to department. You have the catalog that maps to workload, line of business, or business process. Schema to domain or data product. And you have all the table view, volume, function model, which is the lower the leaves, essentially, in Unity Catalog. That maps to factors of production. And then you have a production chain that you can talk about in a meaningful way to your company. So you can then do away with this gold, silver, bronze stuff and talk about the domains within your company. Okay, right, so we're getting to the end now. My advice, my unsolicited advice, or the gobbler way of data bricking. We rely heavily on LDP for our data transformational work. So the goal of what I just said, even though I wanted to get the data to use SQL Server as a bronze layer, why do I want to do that? Because I want to use LDP to transform the data. I cannot, and I forgot to mention that, I cannot use a source that is done by LDP or DLT, as it used to be called, using Lakehouse Federation, because it only goes to a materialized view. A materialized view cannot be used as a source for a streaming table. This is super deep nerdy stuff. Essentially, it locks the door to any kind of any kind of history keeping, and it just makes everything super hard. So, and that's what I want to do. This is also why I did this whole rigmarole with SQL Server. Yes? Who? You? Yes. 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 Yes.
Do we keep that raw data in the bronze layer, or we filter out it based on some condition and store it in bronze? How will manage that data? Do we keep?
So in that use case, that sounds as if you've got a perfect use case for streaming, at least in the outset. I guess that you post all your data to storage bucket. Yeah. So then you use autoloader, right? And you're golden, as you were, or bronze in this case. Ha. Right, so it's sort of I think that's fine. So do you use DLT for this work, or do you structured streaming, or?
Actually, yeah, for kind of streaming. For example, I am reading some room temperature or something like that.
Okay.
Within milliseconds, I am getting dozens of data, right?
Yes.
Lot of data.
Yes.
So all this data we will keep in the as a raw data format in the bronze layer.
Yes.
Or we'll skip.
Yes. None of what I said impacts what you've just said. So it's just what I just tried to do is to give you a framework. I wanted to give you a data engineering state of mind, right? And I tried to get it to fit into my overall story. But for you, your use case, yes, you use autoloader. Either you use Apache structured streaming to sort of utilize the autoloader API, or you use the Delta Live table. It's the same thing, only slightly more managed in the LDP way of doing things. So, all right. So try to use metadata-driven design whenever you can. Do you reuse your code base? This is something that you can do. You can sort of have multiple jobs or multiple pipelines pointing to the same code. As long as you have some kind of table or ini field or something that gives you different results depending on the job, you can do spin up as many jobs or as many pipelines as you want. All right, so we have reached the end. And we are back to where we began with our reference architecture. So what have we talked about today? All right, we have talked about how to move data from SQL Server via Lakehouse Federation into Databricks. We talked about how to use Spark and SQL to meet this objective. We have talked a little bit about Lakeflow declarative pipelines in passing. We have talked about business semantics. Didn't really touch on the quality monitoring, I grant it, but anyway. We have talked a little bit about cataloging. We talked a lot about about the medallion architecture. We talked about storage, didn't we? Good, I like it. We talked about jobs, CI/CD tools, and data ops. And we talked about Lakebase. And these yellow circles are, so all of these are things that we currently, well, apart from this one, that we use in Gobbler. We do not do any AI stuff. So that's aspirational. The yellow circles are aspirational. And in addition to that, we use all of these other things. So I think that we use quite a lot of the Databricks platform. So yeah, I just wanted to give you a flavor of where we started out, what we had talked about, and how it all kind of fits together. All right.